Hello everyone, in today's video we'll be solving this question: sort an array of zeros, ones and twos. So there are two approaches that you can use. I'll verbally tell the first one, which is sort of the brute force, in which we'll be using order of n space. And that what we'll do is we'll take into count the number of zeros, number of ones and number of twos, and then we'll okay, we do not even want to make a new array. Let me code it down. So int count 0 is equal to 0, and we'll have two more such variables, count 1 and count 2. What we'll do is we'll traverse the array once, and then we'll check if a of I is equal to 0. Then count of 0 plus plus, else if a of I is equal to 1, mark count of 1 plus plus, else count of 2 plus plus. Having done that, what we'll do is we'll retraverse this array. Mm, and then we'll put while no, yep, we'll make another variable int k is equal to 0, and then while count 0 minus minus, we'll push a of k plus plus is equal to 0. Similarly, while count of 1 minus minus, a of k plus plus is equal to 1, and similarly while count of 2 minus minus, a of k plus plus is equal to 2. And that is how it will be working in two iterations, and in time complexity of order of n and space complexity of order of 1. That is constant space. Where did we miss this? Okay, yeah. First time I'm implementing this approach, to be honest. I hope this works. Yeah, it actually works. Submit and see. But then that is not the catch of this question. This question is about solving it in place and in one single iteration. See, the time taken is 1.39, and I mean we cannot improve a lot of. I mean, since the test cases are not that big. No, test cases are big actually. We have a test case which I saw that has a length of 65,000 something. So test cases are big, but then we have to decrease this second stake, well, it will be in the order of 1 point something only, at least for the current test cases that we have on GFG. But then we'll have to decrease it. I mean, from 1.39 to, and basically we have to do it in one single iteration and not two, doing it in two iterations. So now what? How are we gonna do this? We'll be using three pointer method, in which we'll be having low, which will be initialized to 0, and the mid is 0, and high is n minus 1. The approach is very simple. The approach is very simple. The approach is mid will be taking care of where the mid is traversing through the array, throughout the array, right? And up till when mid is less than high, it will be traversing that, and it will take care of itself. All it has to do is when it finds a 0, it has to throw that 0 to the left side. Yeah, that's it. When it finds a 0, it has to throw the 0 on its left side. If it finds a 1, it have to continue it in the way it is continuing, like it does not have to make any change. And then if it finds a 2, then it has to throw that into the right side. So we'll do that basically. So while mid is less than high, what it has to do is, if while mid is less than equal to high, it will be, because we have to take into consideration that particular element also. So while mid if a of mid is equal to 0, you have to throw that to the left side, right? So what, how will throw that? We can throw that by swapping, right? Swapping a of l low and a of mid. We threw that. 0 that we got, we threw that to 1, and whatever that in the low we had, we'll take that. What we'll do is low plus plus and mid plus plus. Okay. Now you'll be thinking, ki, why are we doing mid plus plus? Because there can be a possibility that low is already standing at 0. Like low, the element at the lowth index is 0, and the element at a mid is also 0. So 0 gets swapped to 0, and then everyone that's so there is basically no change made. No, no. But the catch is when it finds a 1, it goes forward, right? And when it finds a 0, it swaps right. And then every time it finds a 0 or 1, it will go forward. But it won't go forward when it finds 1, right? So when it finds 1 on when it finds 2, sorry, basically 1 it will go forward, 0 it will go forward. When it finds a 2, it will only decrement the high value, it won't go forward. So the catch of this is, if we have, let's say, swapped the two zeros and we have went forward, this 0 that we have swapped will be, like, in the future become low, right? In that case, that low pointer will take care of itself, right? Or else that belongs to that low ka pura number of zeros ka wo zero. So that is what it is about. And then if a of mid is equal to 1, no need to do, because mid should be, I mean 1 should be in center. And if a of mid is equal to 2, now what will do? You have to throw that to the right side, you have to throw that to the right side, just throw that a of this and a of high. We have thrown that to the right side. No, I don't want 2 in the middle. And what we'll do is we won't increment mid this time, because there can be one coming from there, right? See, in case of 0 it was different, because this 0 that we have left behind can be covered up by the low that is coming forward. But if we if we go beyond, we are not going beyond high, right? We, if we are not going beyond high, because see, the while loop is only up till less than or equal to high, right? So if we leave any twos, then that won't be covered by the high variable, because high cannot come behind this mid. So that is why we are not incrementing mid in this case. We are just decrementing the value of high, and that is what we have to do. And it has been done in place, and you do not have to return anything, and this should be working perfectly fine. Yes, it does. Uh, what is the mistake? Low plus plus, mid plus plus. Yeah. We have to use else if cases now. Yeah. Hmm. We have reduced the time from 1.35 to 1. It is not a like a big reduction, but for the cases when you have a large set of data, it will be of matter. So that is what the question was about, and I hope you have understood the approach. Thank you.